The Big Bang, a Universe is Born, written by Neil deGrasse Tyson, Cosmos, a Space-Time Odyssey. Imagine a time when our vast universe was an incredibly tiny point, smaller than an atom. This point held the potential for everything that would ever exist. It was unbelievably hot and dense, containing all the energy and matter that would become everything we see around us. Then, approximately 13.8 billion years ago, this point expanded in a massive explosion of energy and light, marking the birth of our universe. We call this event the Big Bang. It was the moment when time and space as we know them began. The Big Bang wasn't an explosion like a firework, it was the rapid expansion of space itself, stretching in all directions at an unimaginable speed. As the universe expanded, it cooled down, allowing energy to transform into matter. This cooling allowed matter to form from the primordial energy soup, setting the stage for the formation of atoms. As the universe continued to expand and cool, fundamental particles combined, forming the first protons and neutrons, the building blocks of atoms. These atoms clumped together under gravity, forming the first stars and galaxies, which created heavier elements essential for planets and life. From that initial explosion, the universe has continued to expand and evolve, giving rise to the vast cosmos we see today. And here we are, billions of years later, looking up at the night sky, trying to understand our place in this ever-expanding universe. The universe continues to expand, and with each moment we uncover more of its mysteries. The journey of discovery is far from over. From light to matter, the first elements. In the first few minutes after the Big Bang, the universe resembled a giant nuclear reactor, a place of unimaginable energy and activity. Temperatures and densities were still incredibly high, allowing protons and neutrons to fuse together in a process called nucleosynthesis. This was a time when the universe was a hot, dense plasma, a sea of particles colliding and merging. This fusion created the first light elements: hydrogen, the simplest and most abundant element, and helium, the second lightest. These elements formed the building blocks for everything that would come later. Imagine a cosmic kitchen where protons and neutrons are the ingredients. In this kitchen, the recipe is simple but profound, leading to the creation of the universe's first elements. The intense heat and pressure of the early universe act as the stovetop, forcing these ingredients to combine and cook up new elements. This process was relentless, happening on a scale and with an intensity that is hard to imagine. This cosmic recipe, however, was relatively simple, primarily producing vast amounts of hydrogen and helium, with trace amounts of lithium and beryllium. These elements were the first steps in a long journey of cosmic evolution. As the universe continued to expand and cool, the conditions for nucleosynthesis became less favorable. The universe was growing larger and less dense, making it harder for particles to collide and fuse. The temperature and density dropped below the threshold required for further fusion, leaving the universe with a specific ratio of hydrogen and helium. This ratio has remained largely unchanged and is a key piece of evidence for the Big Bang theory. This primordial soup of elements forged in the fiery furnace of the Big Bang would serve as the raw material for the formation of stars and galaxies billions of years later. These elements would eventually come together under the force of gravity to form the first stars. This early period of nucleosynthesis is crucial to our understanding of the universe's evolution. It set the stage for everything that followed, from the formation of stars and galaxies to the development of planets and life. The precise abundance of light elements observed today provides strong evidence supporting the Big Bang theory and allows scientists to refine their models of the universe's early stages. These observations help us understand the conditions that prevailed in the first moments of the universe. It's fascinating to think that the very elements that make up our bodies, our planet, and everything we see around us were created in the first few minutes of the universe's existence. This connection to the cosmos is a reminder of our place in the universe and the incredible journey that has led to our existence. Out of darkness, stars ignite the cosmos. Following nucleosynthesis, the universe entered the Dark Ages, a time of profound silence and stillness, devoid of light and energy. This era, lasting hundreds of millions of years, was characterized by darkness, with no stars or galaxies to illuminate space. However, this darkness wasn't empty. It was filled with diffuse gas, primarily hydrogen and helium, remnants of the Big Bang. Gravity began to exert its influence, shaping the future of the universe. Tiny density fluctuations acted as gravitational seeds, pulling in surrounding matter. Over immense periods, denser regions grew, attracting more matter and becoming compact. As these clumps collapsed, Their internal pressure and temperature soared, setting the stage for a dramatic transformation. Eventually, the cores ignited nuclear fusion, marking the birth of the first stars, bringing light to the universe. These early stars were colossal, shining with incredible brilliance, piercing the darkness. The formation of these stars marked a turning point, signaling the end of the Dark Ages and the beginning of a new era. Their intense radiation ionized the surrounding hydrogen gas, transforming the universe from dark to transparent. This reionization marked the end of the Dark Ages, ushering in the epoch of galaxy formation, setting the stage for the cosmos we observe today. Galaxies assemble islands in the cosmic ocean. As more and more stars ignited across the universe, they began to clump together under the influence of gravity, forming the first galaxies. These early galaxies were much smaller and less structured than the majestic spiral and elliptical galaxies we observe today. They resembled cosmic building blocks, merging and colliding with each other over billions of years, gradually assembling into larger and more complex structures. Imagine a vast cosmic dance floor where these early galaxies, initially scattered across the universe, are drawn together by the irresistible force of gravity. They waltz and spin, sometimes brushing past each other, other times colliding in spectacular bursts of star formation, ultimately merging to form larger galactic structures. These galactic mergers played a crucial role in shaping the universe we see today. They triggered intense bursts of star formation, fueled by the influx of gas and dust. They also helped to redistribute matter, leading to the diverse range of galaxy shapes and sizes we observe, from majestic spirals like our own Milky Way to giant elliptical galaxies containing trillions of stars. The evolution of galaxies is an ongoing process. Galaxies continue to interact and merge, shaping their structures and influencing the formation of stars within them. By studying these galactic interactions, astronomers gain valuable insights into the processes that have shaped the universe over billions of years, providing a glimpse into the dynamic and ever-evolving nature of the cosmos. The universe itself is expanding, with galaxies moving apart yet still interacting in this grand